All right, today we're doing something a little different. We're going to explore the absolute foundations of artificial intelligence. But here's the twist. Our guide is this amazing set of handwritten notes from way back, like over a decade ago. So let's actually dig in and see what the building blocks of AI look like back then.
Okay, so before we can even get to the artificial part, we've got to ask a much bigger question, right? What even is intelligence? I mean, how do you pin down and define this thing that we all use every single day?
So, according to these notes, here's how they defined it. And it's pretty powerful. It's not just about, knowing stuff. It's the entire process. You have to acquire knowledge, you have to understand it, and then, and this is the most important part, you have to be able to apply it. That simple idea is pretty much the foundation for everything we're about to talk about.
Okay, so let's shift gears from just intelligence to artificial intelligence. And check this out. This is literally what we're working with today. These are the actual handwritten notes where these ideas were first being sketched out. It really feels like we're kind of digging through this time capsule, figuring it out right alongside the person who wrote this.
And boom, here it is, the core definition from back then. Artificial intelligence is the study of mental ability through the use of a computational model. So let's break that down. It's not magic. It's not some sci-fi thing. It's really about trying to understand and, well, replicate our own thought processes, but using computers to do it.
And you know what's really interesting here? The notes themselves point this out. They say that using a term like mental activities makes AI sound a lot like psychology. And that's exactly the point. Back then, AI wasn't just seen as computer science, it was almost like this new field of computational psychology, a way to model the mind.
All right, so here's where we're headed. We've got the basic definition down. Now we're going to look at the components of AI, its three core techniques, how it's different from regular programming, and then we'll jump into some real-world examples from that era.
Okay, first up, the components. And this is so important to get right off the bat. AI isn't just one single magical thing. It's more like a giant umbrella term for a bunch of different fields, where each one is trying to solve a different piece of that mental ability puzzle.
So here are the big ones listed in the notes. You've got everything from the superphysical, like robotics, to something really abstract, like how do you teach a machine common sense reasoning? And then you've got things like natural language processing, or NLP, which is all about understanding human language. I mean, this is the very foundation of the voice assistants and translation tools we use constantly today.
All right, so we know what AI is, and we know the different parts that make it up. But the big question is, how does an AI actually think? What are the fundamental techniques it's using to tackle a problem?
Well, according to these notes, it really comes down to three core steps. First, it searches. It looks through all the possible solutions. Second, it uses knowledge. It doesn't search blindly. It uses what it already knows to guide that search. And third, and this is a big one, it uses abstraction to make the problem simple enough to solve.
Let's zoom in on that last one, abstraction, because it's absolutely crucial. Think about it. When you try to solve a problem, what do? You automatically ignore all the junk that doesn't matter and you focus on the important bits. Well, that is abstraction. And for an AI, it's the ability to separate the signal from the noise. Without it, it would get totally bogged down in useless details on any complex problem.
Okay, so this all leads to a really key point. You might be thinking, isn't this just programming? But how is building an AI different from, say, writing the code for a word processor or a calculator? Well, as it turns out, the whole approach is fundamentally different.
Here's the breakdown. Think of conventional programming like a recipe. It's a static, fixed set of instructions, usually for crunching numbers. AI programming, on the other hand, is, well, it's more dynamic. It's built to handle symbols and knowledge, to represent complex ideas and adapt, not just follow a rigid path from A to B.
All right, that's enough theory. Let's talk about the real world. Where was this stuff actually being used back when these notes were written? Let's see how these big ideas translated into actual practical applications. And again, look at this. We're going straight to the source. This is a handwritten list of applications from the notes. It's like a little time capsule showing us exactly where this tech was already making a difference. Let's break a few of these down.
So in the industrial world, you had AI acting as the brain for control systems, keeping an eye on things like temperature and pressure. And in finance, it was already on the case, hunting for fraudulent bank transactions and even trying to tackle the wild puzzle of predicting the stock market.
And it wasn't just in finance or factories. We're talking about some really high-stakes stuff here. In aviation, early AI was helping with autopilot systems and weather forecasting. And in medicine,
It was being used in devices that measured blood pressure and even in critical systems like hospital ventilators. It just goes to show you, AI has been a part of this crucial, life-saving tech for a long time. All right, so we've been on quite a journey here, right? From the core definitions to how it was being used in the real world. So what's the big takeaway? What's the crucial point from all of this?
Okay, let's boil it down. First, AI is all about trying to model our mental abilities using computers. Second, it's not one thing. It's a huge field with lots of different parts. Third, it thinks using a three-step process: search, knowledge, and abstraction. And finally, it's fundamentally different from regular programming because it's all about knowledge, not just rigid instructions.
But remember, these techniques we've been talking about, search, knowledge, abstraction, they aren't just abstract ideas for a textbook. No way. They were designed to solve real problems. Specifically, the kind of logic puzzles that you can't solve with just a calculator.
And check this out. This is the perfect example of what I'm talking about. Pulled straight from our source notes, this is the classic water jug problem. It's not about heavy math. It's all about logic, planning your steps, and keeping track of where you are.
So I'm going to leave you with the puzzle itself, right from the notes. Here it is. You've got a 4-gallon jug and a 3-gallon jug. No other markings. You have all the water you want. How would you measure out exactly 2 gallons of water? Seriously, pause for a second and think about what steps you'd have to take. That process that's happening in your head right now, you're searching for different combinations, you're using your basic knowledge of how liquids work, you're abstracting the problem into simple steps. That is exactly the kind of challenge that drives the entire field of artificial intelligence.
And that's our look at the foundations of AI. Give that puzzle a shot. Thanks for watching, and we'll see you on the next one.